So this is our last video on functions for now. And really this is sort of consolidating everything we've done by, instead of taking a function and translating it, we're taking a translated function and working out what has been done to it to get from the original to where we are. So really your success criteria here are just that you want to be able to reverse engineer those transformations to determine what transformations have been applied to the function. So in this example, for our first one, we've been told that the graph y equals x squared has been transformed. So we're mapping it to y equals 2x minus 2 squared plus 3. So what I've done here is I've written it out with our y dash and x dash, so to say that it's been transformed to that. And what we want to do is rearrange this until we know what y equaled and what x equaled. So if we were thinking about going forwards, the points where we would be substituting into the equation, we want to go back to find those. So going just slowly, we would have y dash minus 3 would be equal to 2 times x dash minus 2 squared. We'd then divide that by 2, so y dash minus 3 over 2 is going to give us x dash minus 2 squared. That effectively is, we've done y equals x squared, this was y, this was x, and we've got it squared. So we can take those and rearrange them to find out what y dash equals and what x dash equals, because here we have y equals y dash minus 3 over 2, and we have x equals x dash minus 2 squared. So over here, 2y would be y dash minus 3. So 2y plus 3 would give us y dash. Similarly, so I made a mistake here. The x is just going to be equal to x dash minus 2 because our function was x squared. So we're just trying to work out what the x equaled. So rearranging to give us x dash, we would just have x plus 2 equals our x dash here. So in terms of what transformations have actually been applied to this, we would be moving 2 units positive in x. We would be dilating from x, so dilation a factor of 2 from our x-axis, followed by 3 units positive in our y-axis. For the second example, part B, we're taking the graph of y equals root x over to y equals the root of 5x minus 2. So I've just notated that translation just here so we have a little bit more space. So again, we just want to think about it in terms of rearranging so that we know what exactly y equaled and what x equaled. This one's easy to do that straight away because we don't have anything to kind of divide or multiply or move over to the y side. So we would say that y just equaled y dash and x was equal to 5x dash minus 2. So all we need to do with this one is rearrange to find out what x dash was equal to, because obviously the y's are equal either way around. So we have x plus 2 would be 5x dash. So x plus 2 on 5 would be our x dash. Now I'm going to write that as x on 5 plus 2 on 5, because that actually makes it a little bit easier to think about in this case. There's been no transformations kind of from the x-axis to the y-axis, so there's no dilation or reflection from the x-axis. What has happened here is that we've had a dilation of a factor of 1/5. So not a factor of 5, but rather a factor of 1/5 from the y-axis, because we've got x over 5 rather than 5x. Then we have a translation of 2 over 5 positive in our x-axis. Right, so that dilation, if we were just talking about the dilation, it would be that xy would map to x over 5y, or 1/5 times x. So one last example here, a little different to what you might expect. Normally we'd be thinking of taking our base sort of function like y equals x squared, y equals root x, one of those, and transforming it. Whereas here we've said that y equals 5x minus 1 squared plus 6 is our original equation, and we want to know how you would transform it to get to y equals x squared. So y equals 5x minus 1 squared plus 6 is going to map to y dash equals x dash squared. If we think about rearranging, rather than rearranging our transformed function here, we're going to rearrange that original one to be y minus 6 equals 5x minus 1 squared. So now that sort of maps over a little more easily to y equals x dash squared, because we've got the y and we've got just something squared on the other side. So that will work. So we can say that y dash is going to be equal here to y minus 6, and x dash is going to be equal to 5x minus 1. So now we don't actually need to rearrange anything because we're already equal to y dash and x dash, rather than being equal to x and y like we would be in those other examples. So we can see from that we've had a dilation of a factor of 5 in our y-axis, because it's been applied over here to the x. And then we've had a translation of minus 1 in our x and minus 6 in our y-axis.